Hello everyone and welcome to our Cambridge IGCSE Sciences webinar today. I'm Jane Sly from Cambridge University Press and Assessment and I'll be hosting today. So first up, our Head of Science, Carl Saxton, will take you through the key reasons why schools around the world confidently choose Cambridge for their sciences. We'll then hand over to Mark Coventry, who is our Senior Product Manager, and he'll highlight the specific science support available to you, including the experiments on our Everyday Science platform and a walkthrough. Next, Ian Connor, our trainer and examiner, will address the common questions we receive from teachers, such as tiering, whether it's harder to achieve top grades with Cambridge, and questions around practical. After that, Timur, our PD manager, will outline the Cambridge Science Professional Development courses available, including a discount for webinar attendees as well. And if you're interested in taking part in our teacher consultations for syllabus redevelopments, I'll give a quick overview of how you can get involved, and then we have the Q&A. So, Carl, over to you.
Thank you very much, Jane. Hello, everyone. I'm Carl Saxton, Head of Science at Cambridge. Now, Cambridge has a unique and rich heritage in science, and many of the world's most important discoveries began here at our university. When we say it's in our DNA, we mean that our syllabuses are built from the latest research and decades of teaching, learning, and assessment experience. So your learners, whether they dream of becoming doctors, engineers, entrepreneurs, or future teachers, they get a world-class science education with clear progression across the Cambridge pathway that has real-world relevance. Now, of course, one of the realities of school timetables and of our learners is that one size never fits all. That's why our science qualifications are designed around choice. At IGCSE, students can take individual sciences, biology, chemistry, and physics, when they want the real depth and the strongest springboard into AS and A level. Of course, if space on the timetable is tight, Coordinated Sciences provides a double award route, which has solid progression to A level. And for students who need a broad foundation without specialising in science or going on to science post 16, then combined science is a great fit. We also offer science-related options that reflect local contexts and student interests, for example, agriculture, marine science, environmental management. And these syllabuses help learners connect science to the world beyond traditional lab settings. And of course, because students learn at different paces, several of our science syllabuses are tiered, and that is core and extended, and that enables you to tune your teaching so that you can challenge and support precisely with your learners. And we keep practical science at the heart of our experience. At IGCSE, schools can choose between hands-on practical assessments and an alternative to practical. And we provide guidance so that you can deliver practical skills effectively in your classrooms. Of course, in an ever-increasing digital world and AI becoming more prominent, our aim isn't just to cover content, it really is to grow those future-ready learners that are scientific thinkers. Our science syllabuses deliberately blend strong theoretical knowledge with practical competence, conceptual understanding, and higher-order thinking skills such as analysis, evaluation, and problem-solving. That means students who study our sciences can take the next step with confidence, whether that's moving into employment, progressing from IGCSE to AS and A level, following a science-based career path, or they're just simply keeping the curiosity alive that makes science enjoyable. And really importantly, over 2,500 universities in around 100 countries formally recognise our qualifications. This provides clear external validation that the knowledge and skills your students develop are valued globally. Now, great curricula only come alive with great support, and this is where Cambridge really stands apart. We're known for comprehensive, high-quality teaching and learning support. From the School Support Hub to endorsed resources, exam preparation and prep, practice guides, and a strong programme of professional development. You'll find genuine choice in resources in both print and digital formats. And because assessment drives learning, you have access to more past examination resources than anyone else. Now, it's over to my colleague Mark for a closer look at our support ecosystem.
Hello, everyone. My name is Mark Coventry, and I'm the Senior Product Manager for the Science subjects here at Cambridge. And today, I'm going to talk about the School Support Hub and all the resources we produce that will help you deliver the IGCSE Sciences. Now, some of you may be familiar with the School Support Hub already, and it might be new to others, but I'll go over the features and the support available to you. But it's had a bit of an upgrade in the last few weeks, and it still contains all the materials you're used to help you support delivering the science syllabuses, but also a few extra features as well. So on this homepage, we can see we have your subject that you might be teaching, all the resources you want, quick, easy links. The resources that are new get flagged to you, and also you have links to endorsed resources, upcoming events as well, which Tim will talk about later, and links to endorsed resources and any other information you might need for your account. Now, you'll be able to add your subjects into your subject tab on the left-hand side and have all the subjects you teach in one place. So if you're teaching multiple subjects or levels, such as A level, you'll be able to flick between them very quickly and easily. If something is updated, you'll see a little flag saying you've not seen it yet, which will let you know that there's a new document that you might need to have a little look at. But also, we have allowed, in the upgrade, we are having people be able to link directly to objects, but also favourite and rate the materials on School Support Hub, allowing us to get feedback on which ones you like best and which ones we can develop more of. And that feedback is really look forward to. There's main sections on the resource pages. The syllabus is where you have the most up-to-date syllabus information and the specimen papers. Examination resources, like Carol said, we offer 5 years of past papers across all regions. Back a little bit, please, Jane. 5 years of, thank you, 5 years of past papers from all regions, alongside mark schemes and examiner reports. And finally, the Teaching and Learning tab is where you'll find the resources to help you deliver teaching on a day-to-day basis. Thank you, Jane. Here, you'll find the scheme of work, which is a set of medium-term plans to help you deliver the learning outcomes from the syllabus, and also contains suggested teaching orders, as well as lesson activities to help you get started in your planning. The example candidate responses are taken from a live exam, and that's a picture of the organism in the middle there. And we have an examiner produce a realistically perfect answer like a candidate would provide, as well as an examiner comment based off their experience marking this exam series, and it'll help exemplify what a good answer looks like, as well as how to avoid common mistakes, as well as common issues in those types of questions. And finally, we have learner guides, which is something you can give to your learners to give more information about the syllabus for them, what's involved in the examinations, as well as guidance how to revise and prepare their study, as well as a list of learning objectives for them to use to check their understanding against. All of these are stored in the School Support Hub. And if you don't have an account, you need to speak to the School Support Hub coordinator in your school who'll set you up your personal login with your email address. And all these resources are available for all 3 science syllabuses, as well as coordinating combined, but also A-level as well. There is a consistency across the entire support offering. So everything is looking the same and available for every syllabus. We also have other science-specific support available. We have Resource Plus and Everyday Science, and both have different needs and different support available for you, so they can work complementary to each other. Now, Resource Plus contains lesson videos and teacher packs for 10 key practical skills for each subject. They're designed to help teachers in planning and preparing to teach practical skills mostly, but can also be used to help your learners as well. Thank you, Jane. The experiment videos are produced by ourselves. They're high quality, professionally filmed, and they're written by principal examiners here at Cambridge. They're designed to upskill and help teachers have confidence in delivering material. So if you've never extracted DNA from split peas before, this video is an excellent place to start. It shows you how to set up the experiment. You can watch the experiment run from start to finish, give you some sample results and tips to what to expect. There's also a teacher walkthrough version, which is the same video, but has pop-up boxes to help you spot the things you might need to keep an eye on. So double-checking colour changes, safety considerations. And finally, there's a virtual experiment, which again is the same video, but has places to pause where results can pop up, which means that if you don't have the time or space or resources to deliver this lesson in person, or you may want to use it as a catch-up lesson in your teaching, you can run this with your learners and they can collect the results so they don't miss out. There's also a teacher pack for lesson ideas. It's essentially individual lesson plans and resources such as worksheets. So everything you need to teach that practical skill. There's also an alternative to practical lesson, like I said, where you can run the lesson using the practical video instead of the materials. Now, Resource Plus is ultimately designed for teachers who may be unfamiliar with a practical skill to upskill and be confident in delivering it in front of the class for the first time. But if you're a more experienced teacher, you might use a lesson plan to add ideas to your original planning, or use some of the resources like the worksheets to help check the learner's understanding. And you might be a very experienced teacher. You've extracted DNA a million times, but there's still worksheets with examples. So there's something for everyone to use in the Resource Plus packs. And again, I'll repeat this many times today, these are available for all IGCSE subjects and A level too. So the continuity as well. Now, Everyday Science, slightly different, is available for all such syllabuses again, and A level again. And there's 5 projects for each subject at each level. And these are designed using everyday items and following a scientific method. A learner can independently follow clear step-by-step instructions, recording results, thoughts, answer questions, all without a login. So you don't have any accounts to manage. And they can carry out these investigations at home. These were launched in 2022 and have been growing ever since. We've had 12 new activities added last year for all of the subjects, bringing up to 30 in total. And I'm collecting feedback, which I'll show you in a minute, and I'll continue adding projects to these in the future. They are continually being updated and added to. We've got some sharing cards, so you can share them with your learners very easily and quickly. And these are held behind the School Support Hub login. So you visit School Support Hub, you follow a link to Everyday Science without any additional logging in, and you can share them with your learners. You can print them, you can share them through Teams, you can send an email, you can scan a QR code. These are completely device agnostic, meaning that you can use anything you want to access these. They work just as well on a phone, tablet, PC, laptop, anything at all. The website scales correctly. And it fits and works for all of them. I've got a demonstration to show you of an Everyday Science project. I might speak quite quickly here to make it all fit in, but it's hosted on a website called Rise, which looks very nice and swishy and fancy. So if Jane presses play, I'll talk way through what an investigation looks like for a learner. We can start the investigation. After a short introduction, it's linked to the syllabus learning objectives, so they can see exactly what they're learning and what they'll be covering in this activity. It's designed to be run for about an hour maximum, and a learner can come and go without logging in, and their work will be saved. They will be following an experiment to start with. We provide diagrams, there's risk assessments, and there's also photographs potentially to help them. This box here, you'll see a few times, is where learners can type in their ideas, thoughts, answer questions, or the results as they go through the experiment. The experiment themselves, diagrammed, using everyday items, and often we provide alternatives if you can't find coffee filters, so we can use other things instead. And essentially, it will follow and flow through like a normal lab experiment, but they're doing it potentially in their kitchen with normal items and collecting results as well. And once they finish the practical, they'll be asked for their observations. It's guided the entire way through. And that's one half of the project. After that, they'll be thinking about the scientific method, they'll be thinking about the plans, they'll be thinking about the results, they'll be looking at evaluating how they have collected results and looking more at other examples as well. A bit further on, it then moves on to some checking their knowledge, reflecting on what they've done. So there'll be questions, usually kind of things you may recognise in an exam, which can be using to check their understanding, quick knowledge checks, as well as looking at some key vocabulary as well. And these are presented in like a flashcard format. So as the learners work their way through this, they will eventually get to the end of the project, fill in a short evaluation for themselves, a checklist of what they should have learned, filling in the radio buttons. And again, this is saved locally on their machines. And then once you get to the end, they can export all of their notes they have typed up. And alongside their notes, which they have typed into those boxes, there'll be an examiner comment as well, like the author of the piece, including Ian, who we'll speak to later, produced some of these for physics. And that can be exported and shared with you. We also have a feedback form at the end, which comes directly to me. Learners can fill that in. I've had quite a lot of responses this week about some investigations, all positive. And that is the entire everyday science project. There's lots of these. I've seen teachers use them all sorts of ways: homework, project work over the summer, catch-up work if you're teaching like an A-level class, you can give them the IGCSE result things to look at, or you can stretch an IGCSE class by showing them a A-level practical, for example. There's lots of ways you can do it. You can even do it in the classroom if you have the technology and if you have the maybe not enough lesson time or resources to carry out the specific experiment. So very flexible. Thank you, Jane. And we have a few more additional pieces of support available in School Support Hub. We have a test maker, which allows you to make tests using past paper questions for the IGCSE Sciences. We have community forums, which will be launching soon on the new site, where you can ask questions and share ideas with Cambridge teachers, and that's moderated by a Cambridge expert. And finally, teaching tools are easy to use and customizable activities to use in your lessons. Timers, group makers, maps, lots of activities stored in School Support Hub, so you don't have to jump between 5 different websites to find your timer, your group maker. It's all there and works on all devices. Now, endorsed resources as well, the textbooks. We have a wide array of resources available for each science subject. We've got course books, workbooks, digital teacher resources, practical workbooks, the whole range is available, print and digitally on Cambridge Go, which is our sister separate website. And these can be found via links in School Support Hub. Now, another product which launched in the last few years is the Exam Prep and Practice book, which I want to highlight now for a few minutes. These books are not only full of questions, but also sections designed for learners to reflect on the learning. If Jane moves on to the next slide, we'll see some examples of this. Thank you. So it really breaks down the questions. It shows off how learners can be prepared for an exam to help them build confidence, reflect on the learnings, and makes setting goals and making exam practice something that they do throughout the entire course and not just cram into the last few weeks. We have some courses of 400 auto-mark questions, wide range of topics, difficulty levels, and we have time quizzes as well. They're really full of features which will help your learners across the entire course to prepare for the final examinations. Thank you very much. I hope this was useful, and the resources will help you delivering our qualifications. I'm now going to hand over to Ian, who's going to talk a bit more about everything, I hope. Thank you.
Exams. Hi.
Exams.
Thank you. Thank you, Mark. My name is Ian Connor. I am, by way of trade, an examiner and a teacher. Originally qualified as a physics teacher, and these days I spend a lot of my time working with teachers in schools, but also working on exams. I write quite a few of them, I mark a lot of them. And so, what I'm going to do in my little section here, I'm just going to basically talk about exams and give you some information about how they work, basically. And what we've done is we've structured this with several kind of common questions that we get, really. So the first common question we've got here, which science syllabuses are best for my learners? Now, Carl has already touched on some of this, but it's worth just pointing out a few little bits and pieces here for you. The first thing is we do offer lots of different syllabuses. There isn't just a science syllabus. There's a whole raft of these things, as you can see there. And one of our reasons for doing that is, again, to do with, as Carl said earlier on, flexibility. We know that different students have different needs when it comes to science. So, for example, you might get ones who are really keen on science and they want to progress to A level and they want to do all three sciences in depth to enable them to access the A level courses easily. So, for that reason, we have triple award. We've got what we call the double award there, or what some people call the double award. It's coordinated science. Let's say, for example, that your school timetable doesn't have quite enough time in it to allow you to do all three of the separate sciences in depth, but you have got enough time to do both. And you might not want to say to the children, we want you to choose either biology and chemistry or biology and physics. You know, you want them to do a bit of all three. That is the reason why we provide the coordinated science. It is, as you can see there, 2 IGCSE grades. They are identical. And I'll come to the guided learning hours in just a second. We have a single award, which is combined science. And again, this is, it depends what you want to do with it. Some schools, for example, use this for the children who perhaps aren't that keen on science. They don't want to progress with it any further, but they still need some kind of science qualification. Other schools use this with perhaps some learners who have difficulty accessing the science. They find it a bit overloading, so they just do one IGCSE. And again, that's got a bit of biology, a bit of chemistry, and a bit of physics. So they're still getting that breadth of the 3 different sciences. And then we offer these other courses as well. Again, they're quite small, but they're aimed at particular local circumstances. So, for example, in Florida, marine science is particularly a big thing because they've got a huge industry based on the sea, effectively. If we look down that second column there, you can see this tells you about the grading and the guided learning hours. It's worth just pointing out what this means, guided learning hours. So typically we say that an IGCSE qualification should have 130 guided learning hours. So obviously double award 260 and the triple award 390. That does not necessarily mean 130 hours of teaching time. It doesn't mean 130 hours of the teacher standing in front of the class. That can include things like homework, exam preparation, and things like that. So if you pick up a syllabus and look at it and think, oh, we don't have 130 hours, doesn't necessarily mean 130 hours of timetabled time. So the basic idea is it's flexible. You can pick and choose which of these courses best suit your school, best suit your learners, and best suit your timetable. Thanks, Jane. What reasons, how is this a good thing? Well, the long and short of it, as I've just said, it's whatever works for your school. We're very, very keen on not telling people how things should be done. We like to offer people flexibility. So it might be, for example, that you've got a lot of timetable time, in which case you might want to do the 3 separate sciences. You might not have enough time for that, so you might just want to do 1 or 2. Also, we're well aware that schools do have difficulties in recruiting science teachers. We know this is an issue all over the world. It certainly is here in the UK. It is pretty much everywhere else as well. You might not necessarily have the staffing structure that enables you to teach the 3 triple sciences in the amount of depth that you would like. So again, that flexibility is there to allow you to accommodate whatever science course you want to do in your curriculum. And then student progression, already mentioned it. Some students just don't like science. They don't want to carry on with it. They don't necessarily need to be exposed to it as much as some of the others. Thank you, Jane. The next common question is about tiering. We get asked this quite a bit. What is tiering? Why do you offer tiers? What's the difference between them? So let's have a quick look at this. Basically, it's to do with differentiation. We find, for example, that with the best will in the world and with the best teacher in the world, there will be some students who are not going to get one of the high grades. And so for them, let's be totally honest, it's not worth spending 130 hours teaching them stuff that's A star and A, is it? They're not going to get there. So one of the things that we do to help teachers with differentiation is we offer a core route and an extended route. And the idea behind that is it's different grades. So if you've got a candidate who you think is not likely to get an A star or an A or a B, then you might want to enter them for core. That caps the grade that they can get at a grade C. But then again, if that's all they're likely to get, they don't necessarily need to be taught all the really hard stuff. A lot of them find it really off-putting. It actually becomes a barrier to them. If they open an exam paper and see a load of questions that are, hard questions, we do find that they tend to switch off and don't really answer very much at all. However, if you put them in for a core exam, it's a lot more accessible. The questions are easier. The wording is a lot easier. The depth is a lot lower. They find that they've got a better chance at succeeding. So for that reason, we offer these two different levels of exam, core and extended. You'll find in the syllabus, by the way, how do we know what to teach? These days, the syllabus is split into two columns. If your candidates are only going to sit the core exam, you teach all the stuff on the left-hand column. If your candidates are going to do the extended route and access the higher grades, you then need to teach both the core and the extended, both columns in the syllabus. But if your candidates are going to do core, there's no point in teaching them the stuff in the right-hand column. Thanks, Jane. We're also got a lot of experience with supporting students whose first language is not English. We put a lot of time, when we write an exam, it's a very long process. We're currently writing the papers for 2028, so that tells you how far in advance it is. Somebody like me writes the first draft, somebody else then adapts it and vets it and tries to point out all the pitfalls that you fall into when you write an exam. Then it goes to a committee. That committee is very, very keen on stripping out any unnecessary words, any words that might have double meanings, there's lots of them about, and basically making the paper as accessible as possible for the candidates. We're really, really conscious that the majority of our learners do not have English as their first language. So we spend a lot of time actually making sure the language is as accessible as possible. We even do that on the higher papers, of course, but we certainly do that on core. One question that we get asked quite a bit, or a statement that teachers come out with when I've done training, is, well, we don't want to put our candidates in for the core level because it will say on the certificate that they only did core. That is not true. Here you can see in the picture there, we've got a screenshot of an actual certificate there. You can see that both of those qualifications, mathematics and biology there, both of them are tiered. You don't know what level of exam that candidate did. So this idea that, we don't want to enter them for core, it's a bit inferior, people might look down the nose at it a bit. No, they don't. It's not the way it works, because nobody ever knows, apart from the school and the candidate. If they show that to a college or a university, they do not know what level of exam they did. Next, Jane. This is a really common query. In syllabus courses that I've run in the past for teachers, we do a lot of training, which Tim will come on to shortly. One of the questions that comes up is, Cambridge has got this really tight mark scheme and it must be hard to get a decent grade. Again, it's not true. We actually operate this thing called positive marking. So our assessments are no more demanding than other awarding bodies. There could possibly be an argument that because of the way we phrase things and the language that we use, some candidates might actually find them more accessible. But we operate this thing called positive marking. The basic idea is we want to award marks if we can. And that is basically the way that an examiner will operate. When you read a question and you look at a student's answer, my default setting is I want to give you the mark if I can. So unless there's a good reason not to give that mark, we will give it. And this is this system called positive marking. Now, when people pick up a mark scheme, when teachers pick up a mark scheme, we have found in the past that people are looking for absolute perfection. We do marking activities in the courses that we run. The responses that the students give do not have to be absolutely word perfect, but the examiner does need to know that the candidate knows what they're talking about. So one example, I remember a lady on a course that I did once, and it was a question from a physics practical paper, and there was a graph. It was length and resistance, you get the idea. And the graph kind of went upwards and then it flattened off. And it was a 2-mark question, what does the graph show, kind of thing. And the mark scheme said the resistance increases with length and then stays constant. And what the candidate had written was, as the length goes up, the resistance goes up, and then it levels off. And there was a huge debate in the room about how many marks. Some people were happy to give that 2. Some people were really not happy and they wanted to give it nothing. And some people only wanted to give the first mark about the length increasing with the resistance increasing. To an examiner, increase, going up, getting bigger, it's all the same thing. Staying the same, leveling off, being constant, that's all the same. So the candidate's answer didn't match the mark scheme exactly, but it was still worth 2 marks because they've used different words that mean the same thing. So again, if a candidate says, as the length gets bigger, the resistance goes up, it's pretty obvious that they mean it's increasing, isn't it? So we are a bit more generous than people think. It's worth keeping in mind as well that we're not actually assessing their English. It is not an English test. It is a science test. So we're very, very keen to check the science. So the actual wording they use doesn't matter too much as long as it's clear what they mean. There is an exception to that, of course, with certain words. So, for example, cytoplasm and chloroplast. We find things like cytoplast and chloroplasm, which don't exist. So the spelling and the wording doesn't really matter unless it's a technical term that could be confused with something else. Another aspect of positive marking is we use a thing called error carried forward. So, for example, if there's a calculation in part A, and then they've got to use that answer in part B, what happens if they get the wrong answer in part A? Well, okay, they're not going to get the marks in part A. They might get some if they've shown us they're working out. But what then happens in part B is the examiner will calculate the answer using the wrong answer from the previous question. And if the candidate's answer matches the examiner's answer, they will get full marks on part B. That's what we call error carried forward. The examiner spots the error, carries it forward to the next question, and then assesses them based on their previous wrong answers. So it's the fairest way of doing it. We also have other answers that are allowable, but not necessarily correct perfect, which leads us on to this thing called extra guidance. Now, this is not a secret. Some people think it is a secret, but it's not a secret. It's something that we don't publish. Let's just talk our way through this. What we have is, in the examiner's meeting, the principal examiner will prepare the final draft of the mark scheme. And when we publish the mark scheme to schools, we only give you the perfect answers that would, in an ideal world, be the perfect answers that candidates will write. However, we're well aware that that's not how it works in real life, and candidates write lots of interesting things that don't specifically match what we're looking for. So what we have is we have this thing called the guidance column. There's a 3rd column on the mark scheme that the examiners use, which is called extra guidance. And this clarifies things that might confuse examiners a little bit. What we actually want is consistency. We want it so no matter who marks it, it will get the same mark, or as close as, within a little bit of tolerance. And what the guidance column does is it gives extra answers that are fine, that are okay. They're not perfect, but they're okay. But they are worthy of credit. Now, we don't publish this. We may do in the future, who knows, but we don't publish this at the moment. But we're going to show you a little bit of what that actually looks like and show you that things are maybe not necessarily as strict as you think they are. So here's an example of a question and an answer and the mark scheme from a combined science 0653 paper. This is actually a real question from the series just gone in November, a real candidate's answer. And it's from paper 6, which is the alternative to practical. So the question there, as you can see, name a piece of apparatus suitable for measuring 25 centimetres cubed of aqueous H, whatever that is. And the answer we're looking for, of course, is measuring cylinder. This candidate has written volumetric pipette, so therefore it's wrong, isn't it? No, it's actually right, because if you press the button, Jane, there we are. This is the examiner's guidance column. Now, in an ideal world, candidates will use measuring cylinders to measure volumes of liquid. But we do know that there are other ways of doing it that are not 100% correct. Measuring cylinder is the correct answer. But there are other things that candidates may use. We know that in some parts of the world, for example, a measuring cylinder goes by a different name, a graduated cylinder. We accept that. It's not perfect, it's not the answer in the syllabus, but it is not wrong. We know that you could use a burette, or a graduated pipette, or a volumetric pipette, or a 25 centimetre cube pipette. There you go, that candidate has used a volumetric pipette. So from the guidance column, they now have the mark. Okay. We also allow phonetics. We know that burette is a tricky word, particularly for English second language students. So if they put biuret, we'd accept that. It's close enough. You're not going to use a biuret test, I know that. However, we also have things that we ignore, such as pipette. Pipette alone usually doesn't have sufficient graduations on it, and a syringe we wouldn't use for measuring a volume. What that's showing you there is, on the face of it, this student has the wrong answer. However, they don't. They have an answer that is acceptable. So when you look at that in a school, when you download the mark scheme from School Support Hub, you'll be looking for measuring cylinder. But just be aware that we look for a lot of other things as well. Next one, please, Jane. This is from a physics theory paper, an extended physics theory paper. You know, this is pitched at A star and A, paper 4. So we've got the question here: state 2 advantages of using optical fibres in high-speed data transmission compared to electrical signals sent on copper wires. And we've got 5 answers there that we're looking for. So you've got high rates of data transmission, faster data transmission, something about the speed, large amounts of information, it's secure, there's very little data or signal loss, and glass is transparent to infrared. Now, this candidate has put transmits faster signals, which you can see is the top marking point there. No problem, no argument about that. And then there's a second mark there. They have strong durability. Now, you can see we've ticked that. And if you look down that list, there's nothing there about durability of fibre optic cables, but this is the guidance column. You can see it's absolutely massive. There's a load of stuff in here. That first one, A, means allow or accept. Allow bandwidth, etc. That ties in with that first marking point. So candidates might say fibre optic cables allow a wider band of frequencies or a larger bandwidth. That is the same as the first marking point about the rates and the data. If you work your way down, you can see somewhere in there, right down the bottom, the last A there, more durable, lower maintenance. That is a perfectly reasonable thing for a 15, 16-year-old to say. They're not taught that. It's not in the syllabus, but it is not wrong. So for that reason, we will have given them the second mark there about the strong durability. Right down the bottom, we ignore certain things. We're not worried about cost. We don't know the difference in cost. We wouldn't expect them to know that. And TV means too vague. It's more efficient. It's what do you mean by more efficient? We'd need more detail there. So you can see that what we've got on the left there, that the published mark scheme, there's only 5 things we're looking for, whereas in reality, there's 5, plus quite a few other things that are not wrong and so are worthy of a mark. Another paper 6 here. This is from 0654, Combined Science. This is the classic question about closing the switch between taking readings. Why do you turn the circuit off in between taking readings? And you can see there in the mark scheme, we've got overheating, we've got keeping the resistance constant, and we've got something about the cell or battery not being drained. So you can see, first of all, to get the first mark there, the overheating. The second one, to avoid using up the energy of the cell. Well, some examiners might give that for the third mark, but then again, some might not. So what we do is in the guidance column, you can see allow to save the battery so the battery is not wasted. It's similar. We're showing you there that we're not looking for word perfect answers. It's a perfectly reasonable thing to write. We know what they mean. We know they mean to stop the battery being drained. We give it the mark. I think we've got 2 more, haven't we, Jane? Another physics paper 4 here. State the meaning of critical angle. And there in the mark scheme, that is the answer from the syllabus. That is the absolute perfect dictionary definition or syllabus definition of critical angle. Now, have a look what the candidate has written. It does not match what is in the mark scheme there. However, again, it's not wrong. We would like candidates to know the actual definition from the syllabus, but we realise that some write it in a slightly different way. What they've written there, again, it's not wrong. If you sit and think, what does critical angle mean? What the candidate has written there is definitely not wrong, but it just doesn't match what we're looking for. However, in the guidance, you can see it matches that second A there. Allow the minimum angle of incidence at which all light is totally internally reflected. Oh, actually, it matches the third one. Either way, you can have it. The minimum angle of incidence at which no light is refracted. OWTTE means or words to that effect. In other words, they don't need to be those specific words. It's words that mean that. BOD, B-O-D, is benefit of the doubt. So we think you know what you mean. We're not 100% happy with it, but we'll give it to you. BOD, benefit of the doubt. And the final one is from paper 4. It's a bit of biology. I've physicsed you a lot here, so I'm going to give you a bit of biology with this one. Describe the role of platelets in protecting the body from infection. We're looking for 2 things for this one. Clot. Doesn't matter what clots, just the idea of blood clotting, and preventing the entry of pathogens or sealing wounds. Now, candidate there has written nothing about clotting, so they're not going to get the first mark. The second one, it's not perfect. It creating a barrier to stop blood escaping. Well, that's not really what it's about as such. However, if we look at the guidance column, we can see we've got there the idea of a physical barrier. Now, they're saying it's to stop the blood coming out. We want it to be about the pathogens going in, but they've got the idea there is a physical barrier there. So what I'm hoping that you've seen is that, yes, we're actually publishing the mark schemes with absolutely perfect, this is what we're looking for, but examiners are actually looking for a lot of other stuff as well. It doesn't need to be 100% word perfect, but it does need to be, shall we say, not wrong. So I'm hoping from that you can see that we're not necessarily as mean as people think we are. Again, our default position, we want to award the mark if we can. We want the candidates to get marks for what they know, understand, and can do. My final little bit here is about the practical exam. I'm going to rattle through this pretty quickly. Do students have to do a practical exam? Well, the first thing to point out here is every single awarding body, whether it be us or one of the other ones, every single one of them assesses practical work. We do it in a way that pulls out the practical stuff into one paper, so it's not hiding in among all the theory questions. However, we've got to bear in mind that sciences are a practical subject. We're not just developing the subject knowledge, we're actually helping them. If they want to go on and do further study, they'll be exposed to a lot of practical work, so it's in their interest to experience it while they're in school, isn't it? But all awarding bodies do practical work. Next, please, Jane. So we offer 2 style of papers here. We offer, if you want to do a practical assessment on the day, where the candidates actually use practical equipment, apparatus on the day, we offer paper 5. You can see that on the left-hand side there. That's how that would look. And if you don't want to do that, perhaps you've not got the facilities, perhaps you can't organise it on the day, we offer you a paper-based version of the practical paper. And you can see just by looking at those 2 slides there, it's the same questions. It's just the ones on the left can be addressed by doing it actually on the day itself. Others, same 4 marks, it's just done in a paper-based way. With regard to a physics paper, again, same sort of thing here. We're doing stretching springs. On the left-hand side, they will actually stretch the spring in the lab as part of the exam. On the right-hand side, what we've done is drawn a picture showing what they might see if they were doing it. And this is the paper-based version, the alternative to practical. And if you look at the 3 marks available, it's exactly the same thing that we're trying to assess there. At the back of the syllabus, there's a lot of information. Teachers say, well, I don't know what depth to teach this into. I don't know what the examiner's looking for. If you go to the very back of the syllabus, section 5, you'll see a list of apparatus and lots of information about how we're looking for the students to do tables and graphs and charts and things like that. The biggest question that I get asked is how can I improve my students' practical skills? It's a huge question. And some teachers say, well, we do paper 6, we don't need to do practical. Yes, you do. All students need to do practical work in any science curriculum, don't they? It's a practical subject. But we do paper 6. Yes, I know you do, but you still need to do practical work. One easy way of sneaking it in is to get hold of past paper 5s and use them in your lesson as a teaching activity. And so what you can see there is I've taken a question 2. We're doing some food tests. And you get given a set of instructions, what equipment you'll need. You get the mark scheme in the question paper. What I would do is photocopy question 2 and use it as a 20-minute activity in your lesson with your learners. Don't do it as an exam, do it as an activity. And then you can talk about it with your learners and get them to try it. And the final slide here is some physics. Same idea, get them stretching a spring. You might not do paper 5, but use paper 5s in your lesson. Get that question from a past exam paper, have a go at it in the lesson as an activity, and you can train the students into what we're looking for. Thanks, Jay. Over to Tim, who's going to talk about CPD.
Thank you so much, Ian. And yeah, thank you so much. So my name is Tim, and I'm one of the professional development managers here at Cambridge. Thank you. And next slide, please, Jane. So we offer a range of different professional development opportunities for teachers at all stages of their professional journey. So you can find something that meets your needs. On this slide, you can see multiple pathways to professional development, whether you are new to Cambridge or experienced teaching Cambridge or would like to transform your classroom practice. So I'm not going to read everything out, but I will send a link, put a link in the chat later, giving you more like a bigger overview of our courses. Next slide, please, Jane. Okay, and as I mentioned before, you can book any of our PD courses via our professional development calendar, and you can scan the QR code on the slide, and I will put a link shortly in the chat as well. And if you book any of our virtual or online IGCSE courses within the next month using the code SCS10, you will get a 10% discount. However, this discount can be applied on top of the early bird discount, which is 20%, making the whole discount, depending on a course, up to 30% cheaper. So yeah, thank you so much. Use the code SCS10 whilst booking one of the courses that are listed on the next slide. Let me just quickly mention it as well. So as you can see here, we've got IGCSE biology, introduction, focus on assessment, focus on teaching, and marking workshops as well. And also the same for sciences coordinated. And also some of our resources courses that are listed below in March. So yeah, the code is SCS10. Please feel free using that code for the discount. And yeah, we look forward to seeing you in one of our professional development sessions. Thank you.
Thank you, Tim. That's brilliant. Okay, just a little bit about teacher consultations for future syllabus updates. So every qualification needs to be reviewed regularly. And as a research-based organisation, of course, University of Cambridge, there are always new ideas and information being shared that we want to implement into our qualifications. So we gather lots of feedback from teachers through development, through our regional teams, from trainers, from consultations. And obviously we want to implement changes to reflect what you tell us as teachers. So your feedback is incredibly important to us. And if you would like to take part in an online survey or an online interview, online focus group, then you can tell us on the post-webinar survey that I will share in just a moment. But I've just got a screenshot on there just to show you the question that's being asked. We would really love you to be involved. And finally, before the Q&A, we have some new materials for Cambridge IGCSE Sciences to share. Have a scan of the QR code there. We have a brochure now that brings together all the key information on our IGCSE Sciences syllabuses all in one place for teachers, learners and parents. And also, if you're thinking of moving to us, you can download guides for biology, chemistry and physics that compare our content with other awarding bodies. I'm also developing a couple more coordinated sciences and combined sciences too.